In this video, we'll look at modeling with trig functions. This question comes right out of your textbook, page 361, number 7. I'll read it to you. A person who was listening to a siren reported that the frequency of the sound fluctuated with time measured in seconds. The minimum frequency that the person heard was 500 Hertz, and the maximum frequency was 1000 Hertz. The maximum frequency occurred at t equals 0 and t equals 15. The person also reported that, in 15 seconds, she heard the maximum frequency 6 times, including the times at t equals 0 and t equals 15. What is the equation of the cosine function that describes the frequency of this siren? Okay, I wrote down some of those key pieces of information on the side here. So a minimum of 500 Hertz, a maximum of 1000 Hertz, and those maximum occur 6 times, one at t equals 0 and one at t equals 15, and 6 total times is a maximum, including 0 and 15. Write a cosine function. Let's start with the axis of curve. Remember, the axis of curve is an equation, so we write y equals. You can use a formula here. The axis of curve is the average, so you can do max plus min divided by 2. That's 1500 divided by 2. Or you can just look and see what's the middle of these two. Here, I'll show you the formula. Can you see the middle number of 500 plus 1000? If you can't, you just go 500 plus 1000 divided by 2, which gives you 1500 divided by 2, which is 750. The axis of the curve, the middle of the wave, the middle of those numbers is 750. You can do the same thing for amplitude. You can use max minus min divided by 2, but there's an easier way. Just think, how big are the waves above 750 and below 750? Those waves are 250 big. If you can't see that, go max minus min, that's 500, divided by 2, and you've got your amplitude. Okay. The next thing, though, we're going to need a little bit of a sketch here because we got to figure out the phase shift. I'll write PS for phase shift. And, oh, that was supposed to look like a straight line. That failed. Let's see if I can fix that a little. It doesn't have to be perfect, but your sketch should have arrows and should look mostly like a straight line. Okay, y-axis, x-axis. And here's the siren starting at its max at right here at time equals 0, and it gets to a max again at time equals 15. And there's 6 total maxes between, and they should be equally spaced, between 0 and 15, so there's going to be a max here and a max approximate. Again, I'm just estimating. It's not going to be a perfect diagram, but I have 1, 2, 3, 4, 5, 6 maxes between 0 and 15. So the wave looks something like this. Notice I put an arrow, and then it goes down, and it comes back, and it goes down, and it comes back, and it comes down, and it goes back. Again, those are supposed to be perfectly equal segments, and they're not. But it's good enough to give us an estimate on these properties. In fact, we'll have them exactly. This rough graph shows, first of all, the phase shift. Cosine is supposed to start at the maximum at the top of the wave, and this does. It has a phase shift of 0 because the cosine wave starts right at the top, maximum on the y-axis, which this does. That means there's no phase shift. How about the period? This is the tricky part for some people, and why I decided to make a video from this question, is drawing this sketch. A lot of people would say the period is 15 divided by 6. But take a close look here, and I'll walk you through it. There's actually 5 waves. Watch. 1 full wave, 2 full waves, 3 full waves, 4 full waves, 5 full waves. The period is 15 seconds, but it's divided up into 5 full waves. Again, I'll count off the cycles. Look, 1 cycle, 2 cycles, 3 cycles, 4 cycles, 5 cycles. This function does 5 full cycles of a wave in 15 seconds, which means the period is 3 seconds. Okay, well, that'll tell us the letters that we're going to use. You can call this something other than letters. It's the letters of the equation. So my properties are here. the corresponding letters, the axis of curves tells us the d value. I'll put a little arrow here. The d value is 750. Why? Because that's what axis of curve is. The amplitude, that tells us, this arrow's bugging me because it's not pointing right to the d. I'm going to fix it. There we go. The amplitude is 250. That tells us the a value is 250. The phase shift is 0. That tells us the b value is 0. The period is a little bit tricky, but not really that hard. To calculate the k value given the period, it's just the total original wave. This is a cos wave. Originally, cos waves have a period of 2 pi divided by the period. So in this case, k is 2 pi divided by 3. And we'll leave it just like that. I've got my properties, which gave me my letters. Now I can just write my equation. So the equation is y equals, and the equation is always in the format the a first and then the k, b, and the d. So I'll write cos here and leave a space for the a, and then open my brackets, leave a space for the k, and there'll be 2 more brackets like that, and the d. So this is the cosine of, what's the a? 250 in front of the a. What's the k value? 2 pi over 3. What goes in the brackets? X, the variable, take away whatever the b value is, plus the d value. And we can simplify that. There's some unnecessary notation now because of that take away 0. That's just 250 cos times 2 pi over 3, 250 cos brackets, 2 pi over 3x. Notice that the x is beside this fraction, not below. And I don't need this minus 0, which means I don't need the extra set of brackets, plus 750. And so we've written an equation, that is, we modeled with trig functions. Given some information from a word problem, we came up with the equation.